Welcome one and all to the Discrete Mathematics lecture. My name is Yolette Boyle and I'm going to be your tour guide of sorts through the material this semester. For the first time, we're taking discrete math and we're breaking it into shorter videos, each with some specific topic focus. And this way you can watch the video, you can pause, you can look more, you can rewind as you like. Of course, don't fast forward, there's good stuff going on. I want to start out now by giving you a bit of an overview of what it is that you're going to be learning in this course. So what are you going to learn? At the kind of the foundations in some sense of mathematics. You'll be learning an assortment of mathematical concepts and notations, but really in a sense you're going to be learning a new language, the language of mathematics, of mathematical rigor in proof. Some specific topics that we'll cover will be things like order relations, induction, permutations, inclusion, exclusion. You'll understand what this means as we get to them through the term. But again, kind of down at the basics, what I want you to learn, and one of the most important things, is even just how to approach problems, how to approach logic, and how to reason in a precise manner. For example, we'll learn how to write clear and convincing proofs, how to recognize fallacious reasoning when there's something that doesn't follow from something else. And I want to point out that this is not necessarily an easy thing to learn. This is considered sometimes one of the harder classes, partly because it's such a shift from maybe programming or typical standard computer science into something that's very more abstract, writing a proof, for example. So because of this, I want to make sure you check yourselves often and use the homework and things of this sort to give you feedback along the way. The good news is that this is the sort of skill that once you learn it, it kind of never goes away. Okay, more concretely, so there'll be 12 lectures in this course. This and the next one will focus on formal proofs and predicate logic. We'll have a lecture on sets, a couple lectures on functions, then a larger chunk of 3 lectures that will be about counting and combinatorics, a bit about proofs by induction, then relations, and finally the final lecture will be about matching. So just to close this piece up, I want to point out that when we say discrete math, this does not mean discrete like I have an embarrassing package, I'd like it to be delivered discretely. This is discrete like non-continuous. For example, like the integers are discrete set as opposed to the reals, which are continuous. Okay, so see you in the next lecture. Peace.